Welcome back to the session on interpolation with unequal intervals. In the previous session, we discussed divider differences and two properties of divider differences. Here, we shall discuss a relation between divider differences and forward differences, and then two interpolation formulae, namely Newton's divider difference interpolation formula and Lagrange's interpolation formula. If the arguments x naught, x1, etc., xn are equally spaced such that xr minus xr minus 1 is equal to h for r equal to 1, 2, 3, etc. up to n. Then divider delta raised to r f of x naught, that is the rth order divider difference between the arguments x naught, x1, x2, etc., xr is equal to delta raised to r f of x naught divided by r factorial into h raised to r, where r varies from 1 to n. This is the relation connecting forward difference operator delta and the divided difference operator divider delta. We have to show this relation. By the definition of divided difference, we have divided delta f of x naught, that is the first order divider difference between the arguments x naught and x1. We can use this notation also, f of x naught x1 is equal to, by definition, this is f of x1 minus f of x naught divided by x1 minus x naught. Here x1 minus x naught is h, because the arguments are equally spaced. We use h as the difference of intervals. Therefore, x1 minus x naught is also h, 1 by h into, by definition of forward difference, this is first order forward difference delta f of x naught. The second order divider difference delta square, divided delta square between the arguments x naught and x1 is equal to, by definition, this is equal to, we can use this notation also, x naught, x1 and x2, which is equal to divided delta f of x1 minus divided delta f of x naught divided by x2 minus x naught, which is equal to, here divided delta f of x naught is this. Therefore, divided delta f of x1 is 1 by h into delta f of x1 minus divided delta f of x naught is this, 1 by h into delta f of x naught, all divided by x2 minus x0. Here all the arguments are equally spaced. Therefore, x2 minus x0 can be written as x2 minus x1 plus x1 minus x0. This x2 minus x1 means h, this also h, that is h plus h is 2h. Therefore, x2 minus x0 is equal to 2h, which is equal to Here 1 by h is common, 1 by h into delta f of x1 minus delta f of x0 divided by 2h. By definition of forward difference, this is delta f of x1 minus delta f of x0 means the second order forward difference delta square f of x naught divided by here h means 1 factorial into h, sorry 1 into h into 2 into h, that is 1 into h into 2 into h in the denominator, which is equal to, this can be written as 1 by 1 into 2 means 2 factorial, h into h is h square into delta square f of x naught. That is divided delta square f of x naught is equal to 1 by 2 factorial into h square delta square f of x naught. Similarly, we can show divided delta cube f of x naught, that is the third order divided difference between the arguments x naught, x1, x2 and x3 is equal to 1 by 3 factorial into h cube into third order forward difference, that is delta cube f of x naught. In general, we can show that divided delta raised to n f of x naught, that is the nth order divided difference between the arguments x naught, x1 etc. up to x n is equal to 1 by n factorial into h raised to n into forward nth order forward difference, that is delta raised to n f of x naught. That is this is the relation delta raised to r f of x naught is equal to divided delta raised to r f of x naught is same as forward difference operator delta raised to r f of x naught divided by r factorial into h raised to r. This is the relation connecting divided difference delta and the forward difference operator delta. Now, we have to discuss the Newton's divided difference interpolation formula. Newton's divided difference interpolation formula. If f of x naught, f of x1 etc. f of x n are the values of a function y equal to f of x corresponding to the arguments x0, x1 etc. xn, where these arguments are not necessarily equally spaced, then the Newton's divided difference interpolation formula is f of x is equal to f of x naught plus x minus x naught into divided delta f of x naught, that is the first order divided difference between the arguments x naught and x1, plus next term is x minus x naught into x minus x1 into divided delta square f of x naught, that is the second order divided difference between the arguments x naught, x1 and x2, plus etc. plus the general term is x minus x naught into x minus x1 into x minus x2 into etc. x minus xn minus 1 into delta divided delta raised to n f of x naught. This is the Newton's divided difference interpolation formula. By definition, we have to prove this. We use the definition of divided difference. That is, by definition, f of x comma x naught is equal to, that is, the divided difference between x and x naught is f of x minus f of x 0 divided by x minus x 0. That is, f of x, from this we can write f of x as f of x is equal to f of x naught plus x minus x naught into f of x comma x naught. Now, f of x comma x naught and x 1, that is the divided difference between three arguments x, x naught, x 1 is equal to f of x naught comma x 1 minus f of x comma x naught divided by x 1 minus x, which is equal to f of x x naught f of x x naught minus f of x naught comma x 1 divided by x minus x 1. Therefore, from this we can write f of x x naught as f of x comma x naught is equal to f of x naught x 1 plus x minus x 1 into f of x x naught x 1. We substitute this expression for f of x comma x naught in this. Therefore, we can write f of x as f of x is equal to f of x is equal to f of x naught plus x minus x naught into f of x comma x naught is this, that is f of x naught comma x 1 plus x minus x 1 into f of x x naught x 1, which is equal to f of x naught plus x minus x naught into f of x naught comma x 1 plus x minus x naught into x minus x 1 f of x x naught x 1, which is equal to f of x naught plus x minus x naught into, this is divided delta f of x naught plus x minus x naught into x minus x 1 into f of x x naught x 1. Now, by the definition of divided differences. We have f of x, x0, x1 and x2, that is the divided difference corresponding to these 4 arguments, is equal to f of x, x0, x1 minus f of x0, x1, x2, x0, x1, x2 all divided by x2 minus x minus x2. Therefore, from this we can write f of x, x0, x1 as f of x0, x1, x2 plus x minus x2 into this f of x, x0, x1 and x2. We use this expression in this. We can write f of x as f of x is equal to f of x0 plus x minus x0 into divided delta f of x0 plus x minus x0 into x minus x1 into this is f of x0, x1, x2 plus x minus x2 into f of x, x0, x1, x2, which is equal to f of x0 plus x minus x0 into divided delta f of x0 plus x minus x0 into x minus x1 into f of x0, x1, x2 plus x minus x0 into x minus x1 into x minus x2 into f of x, x0, x1, x2, which is equal to f of x0 plus x minus x0 into divided delta f of x0 plus x minus x0 into x minus x1 into this is the divided difference between 3 arguments x0, x1 and x2, that is divided delta square f of x0 plus x minus x0 into x minus x1 into x minus x2 into f of x, x0, x1 and x2. Proceeding in this manner, we get f of x as f of x is equal to f of x0 plus x minus x0 into divided delta f of x0 plus x minus x0 into x minus x1 into divided delta square f of x0 plus etc. plus x minus x0 into, in general, x minus x0 into x minus x1 into etc. x minus xn f of x minus x n minus 1 divided delta raised to n f of x0. which is the Newton's interpolation, Newton's divided difference interpolation formula. Here, since n plus 1 values of f of x are given, f of x can be approximated by a polynomial of degree n. Hence, the n plus 1th order divided difference of f of x can be assumed to be 0, that is f of x, x naught, x 1 etc., comma x n is equal to 0. Therefore, we obtain the Newton's divided difference interpolation formula. Now, we have a deduction from this formula. If the arguments are of equally spaced, that is x r minus 1 is equal to h for r varies from 1 to n. Then, by the property divided delta raised to r f of x naught is equal to forward difference operator delta raised to r f of x naught divided by r factorial into h raised to r for r varies from 1 to up to n. Using these values in the Newton's forward interpolation formula, Newton's divided difference interpolation formula, we can write f of x as f of x is equal to f of x naught plus x minus x naught into divided delta f of x naught is delta raised to 1, that is the first order forward difference f of x naught del f of x naught divided by 1 factorial into h raised to 1 plus x minus x naught into x minus x 1 into this is delta square f of x naught divided by 2 factorial into h square plus etc. in general x minus x naught into x minus x 1 into etc. x minus into x minus x n minus 1 into this is delta raised to r f of x naught divided by r factorial into h raised to r. If we set x is equal to x naught plus some n into u into h, then this implies x minus x naught is equal to u h. Now, x minus x 1 can be written as x minus x naught plus x naught minus x 1, that is equal to x minus x naught is u into h, here x naught minus x 1, or this can be written as negative of x 1 minus x naught, negative of x 1 minus x naught, that is this is h, which is equal to u plus 1 times u plus 1 into h. Here minus u h minus h, that is equal to u minus 1 times h. Similarly, x minus x 2 can be written as x minus x naught plus x naught minus x 1 plus x 1 minus x 2, or this can be written as x minus x naught minus of x 1 minus x naught minus of x 2 minus x 1, that is equal to x minus x naught is u h minus x1 minus x0 means h minus this also h, that is u minus 2h or u minus 2 into h, etc. Therefore, we use these expressions in this divided difference formula. We can write the formula as f of x is equal to f of x naught plus x minus x naught is u h into delta f of x naught divided by 1 factorial into h plus x minus x naught into x minus x 1. Here x minus x naught is u h into x minus x 1. X minus x 1 is u minus 1 h into delta square f of x naught divided by 2 factorial into h square plus etc. plus in general x minus x naught is u h, next is u minus 1 into h, u minus 2 into h, etc. delta raised to r. Here u minus n minus 1, that is u minus n plus 1 into h, delta raised to r f of x naught divided by r factorial into h raised to r. That is equal to, this is equal to f of x naught plus, here h and h cancelled, u by 1 factorial into delta f of x naught plus, here h into h is h square and this h square cancelled, u into u minus 1 divided by 2 factorial delta square f of x naught plus etc. plus, here h into h into h, h is n times h, sorry, here u minus r plus 1, r times h multiplied, therefore h raised to r in the numerator, which will cancel with this denominator h raised to r. Then the remaining terms are u into u minus 1, u minus 2 into etc. u minus r plus 1 divided by r factorial into delta raised to r f of x naught, where u is equal to x minus x naught divided by h. This is the Newton's forward interpolation formula. Thus, when the values of the arguments are equally spaced, Newton's divided difference interpolation formula reduces to Newton's forward interpolation formula. Now, we have an example. Using Newton's interpolation formula, we have to find the polynomial function f of x corresponding to a given data. Here the given data is arguments are x 0, 1, 2 and 5. The corresponding function values are f of x 2, 3, 12 and 147. Now, first we construct the divided difference table. The first order divided differences are 3 minus 2 divided by 1 minus 0. that is 1. Here 12 minus 3 divided by 2 minus 1, 12 minus 3 is 9. Here 147 minus 12 divided by 5 minus 2, which is equal to 45. The second divided differences are 9 minus 1 divided by 2 minus 0, that is 8 by 2 is equal to 4. 45 minus 9 divided by here 5 minus 0, that is equal to 9. And the third order differences are 9 minus 4 divided by 5 minus 0, that is 9 minus 4 is 5, 5 divided by 5 is 1. This is the corresponding divided difference table. And by the Newton's divided difference formula, we have f of x is equal to f of x naught plus x minus x naught into f of x naught x on plus f of x minus x naught into x minus x on into f of x naught x on x 2 plus x minus x naught into x minus x on into x minus x 2 into f of x naught x on x 2 and x 3. Here f of x naught is this. F of x naught x 1 means the first divided difference between the arguments x naught and x 1. F of x naught x 1 x 2 is this, and f of x naught x 1 x 2 x 3 is this. On substitution, we will get this is equal to 2 plus x minus, here x naught is 0, therefore x into f of x naught x 1 is 1 plus x into x minus x 1 is 1, x into x minus 1 into this divided difference is 4 plus x minus x naught is 0, x into x minus 1 into x minus x 2 is 2, x minus 2 into 1, which is equal to, on simplification we will get this as a third degree polynomial x cube plus x square minus x plus 2. Therefore, this is the corresponding polynomial f of x to the given data. If we have to find some values in between the given x values, we have to find, say for example, we have to find f of 4, then we put x equal to 4 in this, we will get 64 plus 16 minus 4 plus 2, which is equal to 78. Now, the Lagrange's interpolation formula. Now, we have the Lagrange's interpolation formula. If y naught, y 1, etc., y n are n plus 1 values of a function y equal to f of x corresponding to the arguments x naught, x on, etc., x n, then the Lagrange's interpolation formula is given by y is equal to, y means f of x, which is equal to x minus x 1 into x minus x 2, etc., into x minus x n, all divided by x naught minus x 1 into x naught minus x 2 into, etc., x naught minus x n into y naught, plus next term is x minus x naught into x minus x 2 into, etc., x minus x n divided by x 1 minus x naught into x1 minus x2 into etc. x1 minus xn into y1 plus etc. plus x minus x0 into x minus x1 into x minus x2 into etc. x minus xn minus 1 divided by xn minus x0 into xn minus x1 into etc. xn minus xn minus 1 into yn. This is the Lagrange's interpolation formula. Here note that the first term there is no the first term does not contain x minus x0. In the second term there is no term that is the x minus x1, the term x minus x0, sorry, x minus x1 is not contained, and in the general term x minus xn is not contained. In the denominator, the first term, in the first term we subtract from x0, x0 minus x0 is 0, therefore it is not contained here. Here in the second term the subtraction is from x1, and the general term, in the general term, the denominator, the subtraction is from xn. This is the Lagrange's interpolation formula. We can interpolate using this Lagrange's formula. This is a general interpolation formula. Thank you for watching this session. Have a nice day.